Hello everyone, so in this video, let us talk about the second problem from the LeetCode weekly contest 367. The problem name is shortest and lexicographically smallest beautiful string. So the problem statement goes like this, that you are given a binary string s and a positive integer k. Now a substring of s is called beautiful if the number of ones in it is exactly k. Okay, now a substring is a continuous, you can say a continuous stretch of characters that you can take out from this particular string. So don't worry, we'll take some example as well. So you're given some string, which is a binary string which consists of only zeros and ones. You have to find out a substring that is a part of this string, a continuous stretch of this string like this, such that it consists of exactly k amount of ones. You have to find out to be it as beautiful, and you have to find out the shortest beautiful substring. If there are multiple shortest, you have to find out the lexicographically smallest one among all of them. Okay. Now, let us first understand what is substring that we have told you. Now, among all those substring, you have to find out the ones which have like the exact key amount of ones. So you have to find out substrings. Whenever I see problems in which I have to find out substrings, in which exact k or something like this is important to find out, the very good technique which comes to mind is two pointers. Why? Because a substring consists of two pointers. Let's just take some example as well. Okay, let's put it here. Okay. Let's say that we'll take the first example only. We have 1 0 0 0 1 1 0 0 and 1. Now what you can see here is that we have to form a substring with exactly three ones. So you can take this as well, okay, or you can have also taken this as well. Okay, these are the two possibles which you can take. Now what you can see here is that there are multiple more as well. Okay, like you could have also taken this as well. But among all of those, you have to find the one which is of the smallest length. And if there are multiple of the smallest length, you have to find the ones which is lexicographically smallest. So the first thing which comes to my mind is that every substring marked by a starting point and an ending point. And when we have L and R, we can do two pointer technique to move these two pointers from left to right and find out a substring that consists of exactly k amount of ones. Whenever I find out that, I will find out the length of the substring. If the length of the substring is smaller than which I've already seen, then I've got a much smaller than. I will take that. If it is exactly same, let's say I have find out two substrings of same length that are exactly k amount of ones, I will put it inside some vector. You can make some vector of answers. Okay, and you will keep on inserting those substrings of length, whatever you have, that the minimum length inside the vector, and then you can sort it out in the end. After sorting it out, the first value will be the lexicographically smallest one. That can be done very simply. Now, how you can do two pointers on this, that's the overall problem now. Let's take some example. Let's say that you have one pointer that is here and one pointer that is moving from left to right. Okay, let's say this pointer is moving from left to right. Okay, now you will keep track of the number of ones you have seen till now between this pointer and this pointer. Okay, let's say total number of ones I have seen till now is, let's say, 0. Now this pointer has seen 1, so it will increment by 1. Then it will move to the next point. It will move here. Then it hasn't seen any 1, it will move to the next point. It hasn't seen any 1, it will move to the next point. It hasn't seen any 1, move to the next point. It has seen 1, so it will increment this by 1. This will become 2. Move to the next one. It again sees 1, become 3. And exactly when it becomes 3, I find out a substring that is between this pointer and this pointer that consists of exactly 3 ones. That is k amount of ones. Now, when I move more on the right hand side of this pointer, let's take this, move more right, this is 0, this is 0. When I moved and find out one more 1, then the overall problem is that now it consists of more than k amount of ones. So in that scenario, I will move this particular pointer to the right hand side also. That is these two pointers. And whenever I move this to like this pointer to the right hand side, the segment now becomes this. So let's say from here till here, because these 2 points mark the boundaries of the substring that we're talking about. So this is removed from the previous substring. So I will decrease this by 1. This will become 2 now. Oh, sorry, this will still become 3 because we have added this one, but I've removed this the last one. So it is still 3, and this can also be a possible substring. So you can take that as well. Okay, that's a complete logic and the code part of the actual logic that you have to do. So this is the 2 pointer technique that you will keep on moving that, and whenever you find out a particular substring that is valid, you will like check out what is the length of it and whether it is eligible for an answer. So we'll push it inside the vector. That's it. That's a complete logic part. Let's move on to the code part now to make it more clear. So what we have done is that this is the answer vector that will store all the strings of the smallest length. This is the minimum length I've taken. The minimum length, as you can see, is 100. So I've taken it to be a larger value than this 100. Okay. Then this is J and I. I and J marks the 2 pointers of the substring. This total marks the number of k inside the substring that the current substring that we're iterating over. Okay. Now for loop is done to move one pointer from left to right. And what we are doing is that we will doing a for loop. And that for loop, what we'll do is that if the total number of substrings, the total number of, let's say, ones in the substring that we have, the current substring that we have, if it's greater than equal to k, then what we'll do is that we'll keep on moving our j, the left pointer, to the right hand side. Okay. So if we have somehow the number of total number of, you can say, ones in the substring more than k, we will keep moving our, you can say, this left pointer to the right pointer. Okay, that is this while loop that is doing here. Now what we'll do is, this is one more while loop, I'll tell you in a minute. Then if I add one more 1 on the right hand side, that is this I is the right pointer and j is the left pointer. Okay, so this is j actually, this is I is moved using this for loop and j is moved using this while loop. Okay, now if I'm adding a 1 to the ith value, the ith pointer, I will increment the total because it is adding to the substring. And if j is moving towards the right hand side, it is removing from the substring. So it is subtracting from the total, and this is adding to the total. In the end, we will just check that whether the total is equal to k. If we have a substring that has total amount of ones equal to k, what we will do is that we will check that whether the substring, so the substring has total number of ones equal to k, but whether the length of it is smaller than we have already seen. So the length is I minus j, that is I minus j plus 1, because I and j marks the two boundaries. So I minus j plus 1 is the length of the substring. So if the I minus j plus 1 is smaller than the minimum I have seen, the global minimum, the global number of substring I have seen till now, which satisfy the condition, if it is less than that, which means that I find out a much smaller substring, I will clear all the substrings I have seen till now. I will mark the minimum length of the substring I have seen and push that particular substring inside the answer vector. Okay. If I somehow find a substring that is of the same length as the minimum, then I will push it again in the answer vector. Nothing to remove. This just marks that if I have two substrings of the same length, then push that inside in the answer vector. If I find out a much smaller one, clear all them and find out the answer, new answer. If it is larger, then we don't require that because the larger ones we just don't care. We have already a smaller one. Okay. In the end, we just sort out all the answers if we have multiple shorter substrings and just print out the one that is the lexicographically smallest, that is just sorting out and finding out the very first because that's the lexicographically smallest and the shortest one as well. Now what is this eventually, like this for loop that I've told you? what you can see here is that, let's take this one example, which is like just some small edge case. You can think of it while drawing out some examples. What you can see is that for k equal to 3 for this example, what you can do here is that I can form a substring like this, but I can also form a substring like this. And what you can see here is that both of these substrings are having the number of ones, that is k equal to 3, but this has redundant zeros in the front. Redundant zeros is not necessarily required for us because we want the one which is of the smallest, shortest length. So what we have done is that after moving my j, so this j will only move to the right if the number of ones in the substring is more than k. Okay, so when we are adding from the I number of one, the number of ones in the substring will increase. In the current substring, it will increase. But j will only move to the right hand side to decrease the number of ones. But if I decrease the number of ones, it can also happen that I just move j one step on the right hand side, I decrease the number of ones, but now I have redundant zeros. I have these zeros, which I also don't require. So what I can do is that I can still move my j to the right hand side, ensuring that I only remove zeros. If I remove zeros, that is not necessarily required for me because these zeros are redundant for me and not contributing to anything. These are just increasing the length. So better to remove them and find out the substring which is of the smaller length. Okay, so this is just to remove the zeros on the left hand side which are not required, redundant, and just only increasing the length of the substring. Okay, so that's a complete code part. You can pause on this code part and read it again. I will also post that in the description of this particular video. So that's a complete logic and the code part for this particular problem. If you still have any doubts, you can mention it in the comment box of this particular video. I will see you in the next one. Coding, and bye.